Welcome to This Is My Architecture. I'm Benjamin from AWS. We are here in Tel Aviv, Israel. Today I'm joined by Tom from Wix. Hi, Tom.
Hi, Benjamin.
Thanks for joining us.
Thank you for having me.
Tom, tell us a little bit about what Wix does.
As you know, Wix is an online presence platform serving about 5% of the world's website with over 700 million unique users per month.
Okay, so right off the bat, you're operating at quite a bit of scale.
Yeah, it's high scale.
And today we wanted to talk about your SLED system. Tell us what SLED does.
So SLED is an end-to-end testing framework we developed here at Wix, and it's mostly based on AWS Lambda infrastructure.
Okay, so testing to test for production changes to your websites. What kind of scale are we talking about for those?
So let's say the average rate for production changes and deployments, I'm talking about unique deployments, is about 400 a day.
All right, so 400 deployments a day, you're going to be testing automatically, you're going to be testing all the time. All right, so how do you test on SLED?
So the first thing we do is SLED is a node library installed on a laptop or the CI machine at build time, doesn't really matter. The first thing we do is that we execute the test. Let's say that the developer writes a simple test, an end-to-end test using Puppeteer and Jest and good and popular open source libraries. The first thing we do is we want to make sure that the user that just invoked the test is actually a Wix developer and it's authenticated properly. So what we do is that we use AWS Cognito along with the built-in support with Google Sign-In. So we make sure that every developer is indeed a Wix developer.
Okay.
So that's the first thing, and we know that the user is authenticated.
Okay, so authentication, what happens next?
So once we're authenticated, we look at the test code you just written. We take the test code itself with all its inner dependency, and we pack it and compress it, and we upload it to S3 with a specific unique ID we give. Let's say it's XYZ, and that's what we call the execution bundle.
Okay.
So once we upload the execution bundle, what we do is that we start running the test with the native testing framework. In this case, it's Jest. And what we do is that we use Jest API and tweaked it. And now, instead of running the test on the laptop itself, what we do is that we start invoking Lambdas, not running the test like it should have been run. What we do is we start invoking a lot of Lambdas. By the way, the average test we have in the major builds in Wix is about 700 different test files. When I say 700, 700 different test files with different Chrome and different Puppeteer instances. And we start invoking 700 of this in parallel, all at the same time.
So using Puppeteer and Chromium, you're able to fake a browser running on Lambda, correct?
Exactly.
And I believe you're using Lambda Layers as well?
Yes, we use layers. We actually use only two types of layers. It's very easy to maintain and keep track of the code and make sure that the runtimes look the same, both on the laptop and on the Lambda. We have one layer with pre-installed Chrome AWS Lambda. It's an open source, very popular library that allows you to install Chromium with all its optimizations and tweaks and have it run smoothly along with Puppeteer on a Lambda runtime environment. The second thing we have is just the standard Jest and its inner dependency. We pre-build and we pre-install it on the Lambda itself. So every time we invoke a Lambda, usually the Lambda is already warm up because you see what's our scale. We already have a Chrome instance ready to be executed along with all the Jest dependencies. So the only thing we need to download from the Lambda, and that's the second part, what we do is that we pass it the execution bundle ID. The Lambda downloads immediately the execution with the test file just brought from the developer laptop, and we start execute it smoothly as if it was executed here, only it's happening 700 times all at the same time.
So every one of these executions has its own sort of headless browser. It is executing a test against your production website, correct?
Exactly. Pure production with the minor changes that the developer just did for its own personal code.
And then once it's figured out sort of if the execution failed or succeeded, how does it report back?
So because it's just a standard normal Jest installed on the Lambda, what we do is that we respond to the original invocation with a simple JSON. And that JSON has everything needed in order for the test originally running on the laptop to determine whether it passed or failed, and if it failed, what were the errors and expectations not being fulfilled. So what we have is we have a developer right here. Again, it could be CI, the same thing, but we get a very, very smooth and very cool developer experience where he just invokes 700 different browsers on his laptop in a matter of, let's say, 2 or 3 minutes. That's it. for 700 different tests.
So it's almost like the laptop or the CI machine doesn't even know that you were running these tests in parallel or you were running them remotely. It's
Exactly.
just happy.
Exactly.
How did these two fit in?
So because we consider ourselves as a full-blown infra, what we can do is that we can monitor and report back to DynamoDB and CloudWatch and better understand the infrastructure and maybe some tweaks and optimizations needed in order to make sure that our uptime is as high as possible and every test is being executed properly and returned properly with the correct message.
So give me a sense of how many of these tests are you running in general?
So I just looked last week. In 5 working days, we have 1.2 million different SLED test executions, meaning 1.2 million browsers executed on Lambda, reporting back and playing around with our production system.
So if you wanted to run this on Lambda and you wanted to run it, say, in like your CI server or one of the developers' laptops, you probably wouldn't be able to do it.
You can try executing 700 browsers on your laptop.
And 2 million executions a week. That's amazing. So I really like this, and I like it because you're using Lambda in a smart way. You're sort of faking the testing environment that you're running on your CI servers, your developers. You're giving them sort of very seamless, smooth developer experience. They almost don't know that it's happening, but you're benefiting from this endless compute. This is a really cool use of Lambda, and clearly you're running at a scale where you need this to be robust, you need this to be stable, you need this to be monitored, so you're using the platform to monitor the system well. So this is really cool, and thank you for sharing it with us.
Thank you for having me again.
And thank you for watching This Is My Architecture.